So the last time we talked a little bit about this data structure or object type called dictionary, which has, it's a sort of a list of key value pairs. Yeah. For instance, here's the dictionary. How I define it in Python is using braces, curly braces. And this dictionary had 3 elements. Like the keys are integers, the values are strings, and you have, the first key is 200, and the corresponding value is Python, and so on. And then we did some operations, so lookup, adding, deleting element from the, the dictionary, looking at the values alone or the keys alone, etc. So just to remind you, we'll do this exercise quickly together, right? So when I do D of 256 equal algorithms, that means append this element to the dictionary. Yeah, so the element which has a key of 256 and a value of algorithms. Yeah, so we do it together here. Or maybe for the sake of time, we're not going to math. We've done it, I think, the last time. Okay, so D of 211 means get me the element, the value corresponding to the key 211. That should give me math. D of 275, or 275 is now part of the keys of this dictionary, and so I should return a key error. Length of D would be actually 4, because I have 1, 2, 3, and I've added this last item as 4. Okay, so I have the length is 4. And then I have 212 in D, that's a Boolean expression, so it returns true or false. And how does it evaluate this? It checks whether 212 is part of the keys of this table. It's a false. 212 is not part of this dictionary or table. When I say databases in d.values, first of all, d.values is a method that returns a list containing all the values in this dictionary, yeah, in the dictionary. So is databases part of the elements of this list? Yes, no, because of this. D.keys, on the other hand, would return a list of all the keys inside the dictionary D. Okay, so it would return 200, 211, 277, and 256. Right? And then here, delete of D of 211 means delete this, entry completely from the dictionary, the key and the value. And then D.values again would return all the values without 211. Okay, so this is what the output would look like. Okay, great. Now we started looking at this exercise the last time. So what do we want to do? We want to be able to parse a song lyrics. It doesn't matter what the song is. Assume that the lyrics is given to you as a list of words, yeah, with repetitions and everything. So every word inside the lyrics of the song is an element inside a list that you're giving it as an input. Okay, we want to do a few things. We want to find what word occurs the most. It could be more than one word, of course, right? Maybe there are ties, 2 or 3 words that occur, 30 times, and that's the maximum. Then I should return these words. So I should return, write a function that will be able to look at, every word, figure out what its frequency in the lyrics, and then give me back the word or words which have the maximum frequency. Yeah, so I want to return a tuple. The first is a list of words, and the second is the maximum frequency, highest frequency. And then I want to write another method that actually filters out the words and give me only the words that occur at least X times. Yeah, so X times is given as an input, and then the function should return only the words that appear more than X times. So X times or more. Okay. I'm going to return this as a tuple, which has a list of all the words, right, and their frequency that is above or greater than or equal to X. Yeah, and I want it ordered by the frequency. So the most frequent word or words first, followed by the next ones, provided that they are all greater than or equal to X. Okay, so let's see how I did this. Let's start by just looking at. I'm going to build 3 functions for these 3 tasks. Yeah. The first function is simple. It takes the lyrics list, so it's a list of words, like here. She loves you. It's just every word in the lyrics is an item in this list. So I'm going to take this list, and I'm going to build the dictionary out of it. The dictionary contains the words as keys, the unique words in the lyrics as keys, and the values correspond to the number of times the word appears. So far, so good. Why you keep coming late today? Okay. So where's the chat? Here it is. Okay, good. So let's see how I did this. Not the only way, but this is one possible way. So I'm passing this function, the lyrics, and I'm creating an empty dictionary. So this is just to create an empty dictionary. And then I'm looping over the words inside lyrics, which is, these items. So for word and lyrics, return first she, then loves, then you, and so on. Okay. So this is what it's doing. This is the loop over the words inside the lyrics. And I check this word. Has it appeared already in my dictionary? Initially, the dictionary is empty, so no word would appear. So basically, I will insert this word and assume that its frequency, or how many times I've seen it so far, is 1. Yeah. So if the word is not in the dictionary, add it to the dictionary, and its frequency so far is 1. Now, what happens is every time I encounter a word, I check whether it's already been encountered before or not. So whether it's in the dictionary or not. If it is in the dictionary, I increment the frequency by 1 because I've already seen this word maybe 3 times already, and now this is the 4th time. So I say my dictionary of word plus equal to 1. Else, this is a new word I inserted in the dictionary with a frequency of 1. At the end, I just return this dictionary. Yeah. The first time it sees she, it's going to put she and 1, then loves and 1, then you and 1, yeah and 1, and then yeah and 2, because now it will get into the if. Yeah has appeared already. Frequency so far was 1, now it's 2, now it's 3, now it's 4, and so on. So far, so good. Is this clear? Okay. So let's run it and make sure that it's working. So we do the following, right? Beatles is this song, and then we're gonna do lyrics to frequencies, and we see what it prints out, right? So it's print a dictionary which contains for every word its frequency. Let's try it out. Okay, I'm gonna call. Okay, and here's what it printed. She appears 20 times, loves appears 13, you appears 36, and so on. Okay? Clear so far? Good. Can somebody tell me now, how can I use this dictionary to figure out what is the word that appears the most, or the list of words that appear the most? Any thoughts on this? This was a question in the exam. What would you do? Any thoughts? Can you at least confirm you're still there? Loop over the values. Okay, so loop over the values. So you have 2 things in the dictionary, the keys and the values. So the question again, Jad, here is I built this dictionary out of my lyrics, right? Which contains for every word, how many times it occurs inside the song. How can I use it to figure out what is the words that appear the most number of times and, list them with their frequency? So maximum of the most common words of keys. So maximum works on lists. Yeah, we can do a maximum of a list. So we can get, these values, rawat. So basically get, dictionary or whatever we called it, Beatles.values. That will give me a list of all of these numbers, all of these integers, and I can get their maximum. And then what? And then take the index of it. So there is no index particularly. Set a minimum value to 0. Okay, Michelle is saying. And loop over the keys, checking if the values of each are bigger than the minimum, and change it accordingly. So what Michelle is saying is the following, right? You kind of do as if it's a maximum. Loop over the, the dictionary item by item, initialize maximum to, minus infinity or 0. And then, each time you encounter a word that has, the highest frequency so far, you store the word and the frequency. And then if you see a word that has higher frequency, you update the maximum and the word. Yeah, that would work. Here is how I did it, right? So I think Rawad and Michelle had, good solutions. So here's how I did it. I did something very simple. I said, okay, get me the values, right? So basically this function takes most common words, takes the dictionary, which contains the frequencies, right? So basically for every word, how many times it occurs. And then I got the values. So basically I got these integers, 20, 13, 36, and so on, as a list. Okay? Then I got best, which is what? Which is the maximum value, the maximum of these integers. What is the maximum frequency? So if I look at these numbers, 36 is the highest. Yeah, if you look at it carefully, 36 is the highest. Okay, so I got at least the maximum frequency. I know the word that occurs the most occurs 36 times. I'm going to now loop over the dictionary, word by word, check if the frequency is equal to my maximum, this best. So the frequency of k is equal to best. Then this is one of the words that occur the most. I'm gonna, put it in a list. So words append, where the list was empty initially. And then once I'm done looping over all the words, I would have accumulated all the words that have frequency equal to my best frequency, or the maximum frequency, 36. Not the only way, this is how I've done it. Okay, let's test it. Let's just, first print, right? I want to print these two things first, right? Values to show you what it does, and then print best. Okay, that's what I'm going to print. Let me remove this. We already know what the thing is. Okay, so I'm gonna run the code again. Okay, I didn't call the function. Here it is. Okay. Yeah, I have to construct the methods. Give me a sec. What did it say? Okay. Have an extra parent. Okay, so it is what it did. Right, the function, right? I just made it print what it's doing. So it got me a list, the values, which are all of these values, right? These are 20, 13, 36, 28, and so on. Okay, so just a list of all of these. These are the, the frequencies dot values. And now out of these, I did the maximum of this list, and that gives me 36. And now I use the 36 to loop over all of these, items one by one, check if the frequency of this word is 36, yes or no. Okay. So let's just run it to check if it actually works as intended. Okay, so I'm gonna comment this out. We don't need this, we don't need this. And now let's print what the function returns. It returns two things, a tuple, which contains the list of words and the maximum frequency. Okay, let's try it. And here it gives you two things. A list, which contains only one word, because, you happens to be the only word that appears 36 times, and 36 are the maximum frequency. Questions? If you notice, we're starting to do real programs, yeah? So programs that involve multiple functions, that will, combine multiple things like, lists and loops and so on. Yeah? So expect from now on that we'll be doing this large programs that, achieve multiple things. Questions? Okay, good. So I've solved the second issue. So I want to do two things, right? I mean, I solved the second part, right? So this is the second problem. Now, the third problem is I want to find a word that occurs at least X times. So out of this, I built the dictionary, I can use it because now for every word I have its frequency. How can I go over this and get only the words that appear, more than X times, more than 5 times, for instance? but I want them returned in order. You know, so basically, return a list of tuples where each tuple is a list containing all the words that appear, you know, 10 times, and then 7 times, and then 6 times, and so on. So I want to order them based on frequency. Any thoughts? First of all, forget about the order. How would I get? When I said fix, when did I say fix? Not sure when. I don't remember saying fix. Fix in what context, Rawat? Okay, so back we can keep this question till later, Rawat, because I don't understand what you're saying. Okay, so here's what we're trying to do again. How I can pass over this list and figure out which words appear more than X, where X is an input from the user. Any thoughts? This dictionary. I'm not sure if I'm lagging or what is your issue today, but again, I'm gonna repeat. What is, you know, your any thoughts on how to do this? Go over this, you know, list of words and just output the ones that have frequency greater than X. It loops over the items, the pair, the keys, and the values, right? So when I did a loop over dictionaries, right? In this function, right, I was looping over the dictionary. For k in frequencies, it gives me the key, right? So basically, it's the key. That's what you're asking. Yeah, so k would be the keys. All right. So Michelle is saying the following: loop over all the values, and if they are equal, greater than, you mean, or equal to X, we append the key to a result list. Okay, but how do I, you know, figure out the key from the value? So really, I can do the opposite, Michelle, right? I can figure out the value from the key. You give me a key, and I can give you back the value, right? But I can't say just get me all the keys that are associated with a certain value. In fact, we did it here by looping over that. So we got the value and then looped over the elements and checked whether it's equal to that. Let me rephrase my question. Can I figure out, can I use this function somehow to find out this? So imagine, right, that X is 5. I'm giving you X as 5. Can I use this most common words to figure out, right, all the words that appear more than, you know, 5 times, and actually also print them out in order? Think about it a little bit, right? So this function gave me U and 36. Yeah, when I run it, it gave me back U, right, and 36 as the most frequent word, and the highest frequency is 36. Okay. So let's say I give you X greater than 36, 40. Okay. So I say X is 40. Give me all the words that appear, you know, more than 40 times inside this lyrics. What should you return if X was 40? Nothing, exactly, right? Okay. What if it was 30? If it was 30, any words that appear more than 30 times here, 30 or more. Is there any word that appeared more than 30? You, right? Okay. So here's how I'm going to use this function. It's only the maximum one, exactly that. So here's how I'm going to use this function to do the other task. Let me do the following. Let me say, okay, give me the most frequent words with their frequency, and I check if this frequency, you know, like the maximum frequency is greater than X, then this word should be part of the list. And I know that this is the most frequent word, so should appear the first element. All right? So that's the first thing. Get me the most frequent word, check if it's greater than X, or the list of most frequent words, check if their frequency is greater than X. If yes, I'll put them as the first element in the list. Okay, then delete this guy. So delete U and 36 from the dictionary. And now get me the second most frequent words with their frequency. And check if this frequency is greater than X. If yes, we output this list of words with their frequency. And now we know that these are the second, so they should be really the second element in the output list. Then delete this guy, and so on. This is just one way of doing it. Of course, you could loop and do checks and then do another loop. But here is a way of using the previous function in a smart way to solve my problem. Okay, let's see what I mean by this. Here is the words often. It takes two things, the dictionary with the number of words and this minimum times, the X, yeah? So this is my X, how many, times I want the word to appear at least. Okay, the result is an empty list, which would contain, basically a tuple of two things, right? The list of words, and it's a list of tuples, right? And each tuple contains of a list of words and their frequency greater than this minimum times. Okay, so I'm gonna do a loop, and I'm gonna get the most common words inside frequency. And I check if temp of 1, remember that this returns two things, a list which contains words, and the second element in the tuple is the frequency. So I'm gonna check temp of 1, right? Temp of 1 returns, if you see what it returns, let's see. Just to show you what it prints. Okay. Words. Gonna clear. Here's what it prints. It prints U and 36, okay? U and 36. Yeah, right. So this is printed from the previous method, right? So it prints the most frequent word, then the second most frequent word, and the third, and the fourth, and so on, until I hit my my limit, which is 5. Right? So basically, this is what it's doing. Okay. So remember that each one of these guys is just a tuple of two things: a list of words and the frequency. So I'm going to check the second element in this tuple, temp of 1. Is it greater than or equal to X, my minimum times? If it is, I append this to my result, the output. Right? I append the whole tuple, which contains the words and their frequency. And then I delete this guy, delete these words. So I loop over all the words in this list. So now here I have only U, right? So I'm going to just delete U from the dictionary. Yeah? Frequencies. Remove the word from dictionary. Okay, and I keep looping until I reach, any, word that has a frequency less than min times. This means I've got all the words that appear more than, greater than or equal to X times, and I can stop and return the results. Okay, so let me comment this out, and let me finally print this. That's right. And here is what it prints. It prints U, 36, yeah, 28, C and 20, love and 13, no and 11, B and 10, and an 8 that, should and glad, all of them are 7, and love at 5. So only, where is it that feel more than? Questions? Is this difficult? So the assignment is more or less on this level. So if you look at the questions in the assignment, it really needs some, multiple functions to coordinate together to do a certain task. Questions? Who finds this difficult? Okay. Questions? All right, guys, let's move on. Why we use del? Why we use del? Because of the following. Right? If we don't use del, let's try to remove this part. Yeah? You want to remove this part. It will always get the function, the code to this function, right? Temp equal most common word will keep giving me the same word, right? So give me U36, U36, and so on. Yeah. So really, this is what's gonna be doing. So that's why I want to delete the most frequent word so that I can call the function again and gives me back the next most frequent word. Jad, I'm really sorry that you're facing a lag. It seems the internet is not great today for some reason, and yeah, I can try. Let me try the VLAN and then tell me if this is better, the DSL. We can do a loop from 0 to min times. And, okay, Khaled, and then do what? I'm not sure I understand. So you're saying we can do a loop temp of L? What is temp of L? Is this better? Are you still hearing me? I put the DSL. Are you still connected? Hello? Okay. 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 So now I'm back, right? I tried the DSL. It's not working well. Now I'm back. Is this better? Now you can hear me? Okay. Okay. Good. So we'll try. I don't know. Maybe it's the weather because it's raining. Something is happening with the Wi-Fi. All right. So let me share screen again. It's already shared, right? You can see my screen. No? Okay. Now you can see it, I guess. Okay. Good. So somebody was asking a question. I think Khaled, right? So Khaled, can you repeat your question, please? Khaled, are you still there? If you're still there, please, can you repeat your question? Okay. If you do a loop from 0 to min times. Okay, so we're doing a loop from 0 to min times. And then? And then we use the variables as index for temp. So temp has two elements only, Khaled, right? Temp is what? Temp is a tuple, like this. We've seen this already, right? So let me print temp for you again. So temp gives you back a tuple which contains a word or a list of words and their frequency. Yeah. So basically, it could give me you and 36, or you and hey and yeah and 23. So it has two elements only. So I don't see how you're gonna say index, from 0 to min times. It will give you an index out of range because you have only 0 and 1. It's a tuple. It's two things. A list of words and their frequencies. I'm not sure where you want to get with this. Why I suggest the following: try this out. The code is on Moodle. Try it. Try to write these functions in a different way and see what you get. Yeah, it's a good exercise. Please do this exercise on your own again. Okay. Other questions? Okay. So you have also the code in the slides. You can check it. Again, this is not the only way to do this. This is just one way that I chose to solve this problem. Okay, I'd like to end with another exercise which we've seen before. Right? So tie Albert dictionaries with recursion, which I know you don't. It's not your favorite thing, recursion, but we'll have to deal with it. Okay, so who remember what this function is doing? The one I'm showing in the slide right now. Anybody can tell me? Any thoughts? What is this function doing? Return the Fibonacci sequence. Exactly, right? So I give it n, which is a positive integer or a non-negative integer, and it returns back the Fibonacci back. We've done this before, right? I wrote it recursively, so I'm saying if n is equal, I have two base cases. If n is equal to 0, I know the 0 Fibonacci number is 0. And if n is equal to 1, I return 1. Else, I'm doing two, recursive calls, because Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. So Fibonacci of 2 is going to be equal to 1 plus 0, and so on. Okay, so we have two recursive calls and two, base cases. Okay, so let's see how this function executes. This code is really inefficient. That's the first time we talk about this concept, inefficiency or efficiency of a code. We're going to see this more, maybe not in this course, but in later courses. It's one of the most important things for a computer scientist, is you write efficient code that finishes within reasonable time. We'll see how this is not the case. So why this algorithm or code or program is inefficient? Let's see why. Let's say I'm calling this program with n equal to 4. So I'm going to do Fibonacci of 4. That would give me Fibonacci of 3, right? So I know Fibonacci of 4 is equal to Fibonacci of 3 plus Fibonacci of 2. And Fibonacci of 3 would call Fibonacci of 2. And Fibonacci of 2 would call Fibonacci of 1, which is the base case. So I'm going to go to the second base case, which is Fibonacci of 0. Okay? So basically, this 4 has called, Fibonacci of 3 plus Fibonacci of 2. And Fibonacci of 3 has called Fibonacci of 2 plus Fibonacci of 1. Fibonacci of 2 has called Fibonacci of 1 plus Fibonacci of 3. Both are base cases, so I can, proceed. Yeah, so basically I'm going to compute these values. And then here, remember that I had a call for Fibonacci of 1. Yeah, so I'm going to, this is also a base case. Okay, so I'm going to do this. And then Fibonacci of 2 would call Fibonacci of 1 and Fibonacci of 0, which are all base cases. So what is happening here? What I'm trying to show you by this is that I'm calling the function or recalculating the same values many times. So Fibonacci of 1 and Fibonacci of 0 is called here, called here, called here, and here. Fibonacci of 2 I calculated here, but I also again calculated here as I'm executing this for 4. And imagine if it's Fibonacci of 5, right? So I was calling the function for 5, then I would repeat all of this, and then for Fibonacci of 3 I also repeat it here again. Yeah, so the idea is that my calls here, let's say we call it over 5, right? So over 5, that would mean call over 4 plus over 3, right? So f of 5 is equal to f of 4 plus f of 3. And f of 4 already is f of 3 plus f of 2. So here is, I calculated Fibonacci of 3 here, and I calculated again here, right? And the higher the number is, the more of these calculations you will repeat. Yeah? Because in Fibonacci 3, I'm going to calculate Fibonacci 2, and so on. Okay? Here is a way to make this efficient. Okay. Here's how I can make this more efficient. Fine. I'm going to use a dictionary. Okay. Let's see this notion. This is called memoization. Yeah? You remember values so that you don't compute them again. So my function Fibonacci would now take two parameters. And the number, I want to compute the Fibonacci value for. So where in the sequence I want to compute the, the value, and a dictionary which contains values that I've already calculated. Okay, so the dictionary initially contained 2 elements. What do you see in these two elements? Who can tell me what are these two elements? Who can interpret what is this D so far mean? Any thoughts? 0, 0, 1, 1. What do you think this is? Fibonacci of 0, correct, Rawat, and Fibonacci of 1. Yeah, so I'm going to store the base cases, the values I already know, I don't need to compute, initially in the dictionary. Okay. Now, what I'm going to do is I'm going to call my function. So instead of the base case being 0 and 1, I have two base cases. I'm going to check if my value is already in the dictionary. So if you give me any n, let's say 5, I'm going to check is 5 is part of the keys of the dictionary. Have I already computed Fibonacci of 5? If I have, I return this value. Right? So if I, you give me n equal to 5 and I've already computed f of 5, just return it. Don't, recompute it again by doing recursive calls until you hit the base case. So that's the first part. Else, I haven't called the function, right? So I haven't really computed Fibonacci of n. So what do? I use the recursive call. So I'm going to say Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. And I get this answer, right? So once the recursive call is finished, store it in my dictionary. So I say D, the n Fibonacci number is this answer. And then I return answer to the. So the next time I compute f of 4, if this was giving me an f of 4, the next time I'll find it in the dictionary. Okay. So basically here when I do, let's say, f of 4, it will do f of 3, right? F of 2, f of 1. F of 1 is in the dictionary, so it's going to return it. Right, so I know that this is f of 1 and this is f of 0. Both of them are in the dictionary, so they're going to be returned. Okay, so that will be replaced by 1. That will be replaced by 0. Okay, because they are in the dictionary, so I have this base case. And now f of 2 is going to be equal to 1, right? So answer will be equal to 1 here. I will insert in the dictionary 2 and the value 1. And I'm going to return this 2, right? Sorry, 1 to the caller. And then f of 3 will be computed and its value stored in the dictionary. So the next time I call f, here for instance, I need to call f of 2 again, because f of 4 is equal to f of 3 plus f of 2. And instead of repeating this all the way to the base case, I'm going to just look it up from the dictionary. I know that it's fine. Okay, this is what is called memoization, something that you should be trying to do in your code, right? To avoid, any unnecessary loops, any unnecessary recursive. Just so an example of this. Let's run it and see what this means. Okay, so here is the Fibonacci. I have the two methods, the one that doesn't use the dictionary, okay, and the one that uses the dictionary. And I want to show you the difference between the two. Why one is really more efficient than the other. Okay, so I'm going to run these two methods. First, the efficient one, the inefficient one, and then the efficient one, which uses the dictionary. Okay, and I'm going to record the time. So basically, I'm going to say, before you call the function, before you compute the Fibonacci number, what is the time now? What is the time after the function finishes? And that gives me the running time of this function, how much time it took in seconds. Yeah, so this is what I'm going to do. And then I'm going to run the efficient one, compute the time before I call it, the time after I call it, and see how much execution time it takes. Let's try it out. So Python Fibonacci py, and I'm going to give it the value, let's say 5. Okay, so it's going to tell me, okay, using Fibonacci, the fifth Fibonacci number is 5, and it took me, this insignificant time. So basically, something 10 to the power of minus 5 seconds. Yeah, so almost negligible. You didn't even notice that it was run. Okay, the efficient one take half of the time, but both of them are very small. It doesn't matter. Both of them give me the value of 5. Let's try it for another value. I'm going to try it for 10. So using Fibonacci, again, very few seconds, doesn't matter. And both of them give me the value 55. Okay, this is much less than this, but you don't notice it because both of them are still small. Okay, let's try it for something bigger. 20. Using Fibonacci, it takes me this amount, and the number is 6765. And right for the other 165. I want to show you, Khaled, what is the time for? I want to show you, why the second function is much faster. You see, you can compare, right? This is the time it took the first function without the dictionary, and this is the time it took the second function with the dictionary. Which one is faster? Which one? Can you read these two numbers and tell me which one is smaller? The second. The one with the dictionary is faster. Exactly, right? Let's try it for a bigger number. So 25. Okay, it's taking 0.8. Now let's try it for something big, really big. It's still computing, the Fibonacci number for n equal 35. It took me 6.59 seconds to compute it, right? Without the dictionary. With the dictionary, it finished super, super fast. So the point is the following. Right? If you keep doing these unnecessary recursive calls, this consumes a lot of time. It's like doing loops that you don't need. Yeah, just a hint about efficiency so that when you get introduced to it later on, you understand what that is. Yeah? If we do this for a larger value, the difference will be even much bigger. So now it's calculating, for 40, it's doing all of these recursive calls and repeating recursive calls and just taking a lot of time. Still hasn't finished. God knows when it will finish, yeah? Okay, this code is also on Moodle. The only new thing here, so I called just the two functions, one is Fibonacci and one is Fibonacci efficient. If you're interested in general in knowing how much time does your program take, here's a technique to do this. You import time, it's a library like this, and just say, okay, get me the time now. So start will give you the time right this moment, yeah? And then you do a function, so we'll call the function, the interpreter will execute it, do some steps, it will take some time. And then you say, give me the time right now. So you did the time before you called the function, the time after you called the function. The difference between the two is the execution time of the function, okay, in seconds. Has it finished? No, it hasn't, right? Okay, that's all I have for you today. I encourage you to do the assignment. It will be, it finished, so it took 76 seconds, and the other one took, nothing. And look at the number, it's huge. But the first one took 76 seconds. The second one took almost, nothing. We didn't even notice. Yeah? So huge difference just by using this idea of memoization or dictionary. Okay, I encourage you to do the assignment. It's really not long. 3 of them are from the exam and the rest are on dictionaries. Yeah, it's a fun assignment. It should be relatively easy. And please do these 2 exercises that we've discussed in class today. They're very important. Do them on your own again. All right. We'll finish a bit early today. And we'll start a new topic on Friday. If you have no questions, you can leave. Thank you, Rawat. Thank you, Khaled. Thank you, Dad. All right, thanks, everyone. Share.